Okay, please go Moodle week 11 and download these workflows. For the for the first workflow, which is feature selection H2o, when you open it, if you haven't worked with the H2o modules, it would ask you to install and update. So please let it do. It might take like a couple of minutes for you. So I just give you a few minutes to download this workflow, and please open H2o workflow and let it get updated. So you will have access to several new nodes. Then we go over the first one, which is more on data preparation workflow. Okay, so this is actually look at your assignment number 7. If you for the CSV file, for the data entry, instead of IMDb, please click and browse to the hotel reviews CSV file. Do you see here? I have a CSV file for hotels. Please insert in. If you don't know where is it, please go to Model Assignment 7 and download the hotel review CSV file. So as you see, I built on top of the IMDb workflow that we already worked with. I just added so many extra nodes. So there's I made meta nodes. So it looks much concise, but inside each metadata we have much more nodes this time. So you might remember in your hints, I said when you want to do prediction, your dependent, if your prediction is classification, for example, hotel reviews. So is it like 1 star, 2, 3, up to 5? It looks numeric because 1 to 5 was actual categories, right? Or so in order to use classification problems, you need to convert those numerical values to a string. So as you see, for the review rating, I just included to be converted to the string. Press OK. If you do that, let me show you before and after. So when you import the CSV file, if you go to file table, Next to review rating, there's I, means integer. But we said it should be categorical or string. But for something like date is a string. So province string S stands for a string. Since we want to do classification problem, we need to convert this format to string. Having said that, in the data document creation one, I added a new node for number to a string. So when you click on it, you see that in the green side, which is for inclusion, I said reviews dot rating should be converted to string. So and after, if you do that, now next to the review dot rating, we have S. It stands for string. Any questions so far? Okay, good. So for the, if you go to pre-processing, I didn't do that much of thing. So and I'm skipping these parts because in one of your classes we talk about each note. But basically, we just convert our sentence to something Knime friendly. Meanwhile, we get zero numbers, low number of characters, and we just make a bag of words. At the end, we just focus on the words that have a certain frequency. So if they're less than amount, we just exclude them. So if you row filter, as you see, if it's less than 20, just get rid of them. So far is very similar to the previous one, but there's a catch. So let me open the file again, the file reader, right click and file table. So in the IMD one, we just use this text, review text, to predict review rating. By the way, for today class, and also for your assignment, let's just predict this one, the categories. So if you want to predict categories, you don't need to convert review rating, but this is just for learning purposes. So let's say the categories is a type of hotel is my dependent variable. And I have a review of text for it. So you might say we have other informations, like look at here, like title, city, province or state, zip code, country. So these are some other informations, why we shouldn't use them, right? If you just use the text to predicting the hotel categories column, we just, I mean, disregard so many extra information that we created. So what about even dates? Maybe in the weekend, there is more customer and the service level of service is low, but in the maybe weekdays, they have provide a better service. So this could be also important. And similar to the textual document, so we need to convert to a numeric equivalent because machine learning algorithms just use numerical values as their entries. So the purpose of today's class is not just use review text, but also we are interested to use other columns and more information, maybe better prediction. So it's the reason, look at the pre-processing meta node. It has two branches. One branch goes to document vector. You might, if you remember, this one converts your textual document to numerical equivalent. So what it does, it takes it for me to be loaded. So oh, here, sorry. So for example, first document, row 0 has, look at first different quarter, enjoy atmosphere, history, color. By the way, we exclude some characters and words, so it's the reason maybe it's not a complete sentence. But as you see, in front of that sentence, since we have a word of trip, for trip is 1. For French, we have French, so it's 1. Similarly, to look at row 12, since we have trip, let me see, in here, so the column of trip is 1. But we don't have enjoy, even if it's a typo, that's okay. So we don't have an enjoy with I, which is typo. So it's the reason for row 12, that value is 0. So, but we don't have other columns. It just have it's just a textual column. But we did the job. Actually, we know that column document is just a text. It's not acceptable for machine learning algorithms that we use later. We convert them to so many numeric columns that just 0 or 1. So what I do, I make two branches from preprocessing. One goes to document vector, and the one goes to joiner. So in join, based on row ID, which is the similar ID number, I join these two columns. So if you right click on joiner and go to join table, so first you see the textual document, then some numeric columns, which are just dummy variables 0, 1, showing that if there is a word is in that document or not. When I go to the right side of the table, just now, do you see I have other documents like review title, reviews, date, provenance. So I haven't lose any information here on top of the previous textual document that converted to numerics. I also added the previous columns that because they might have a valuable information that could increase my prediction. I give you a couple of minutes to review these nodes that we have. So far, we had 2 meta nodes and 2 other nodes. Maybe you want to open and just discover by yourself. If you have any questions, you can ask me. So I give you a few minutes to do that. So go over each node and see if you have any questions. Since I don't see your face, I should give you a little bit of time to just discover by yourself. By the way, using meta nodes is a good practice. So otherwise, your page would be so crowded. For doing meta nodes, you just select as much as nodes you want, right click, and create meta nodes. You see? Now it's even much smaller. Okay, I have to rerun it again because when you make meta nodes, it just doesn't go that way. So, okay. Any questions so far? Okay, let's open the Excel file for hotel reviews. And let's go over the province. By the way, I mean, province is just a geographical unit usually outside the United States. So the government that doesn't have federal systems, they instead of states, they have province. So for US, maybe we should just rename it to a state, not province. But look at here, we have AL, stands for Alabama, AZ, Arizona. But we have Bulk Creek Village, Bunker Hill Village, whatever, Bear Oak, Elkhorst, whatever. Westminster is a like Massachusetts, is a city in Massachusetts. So some of them are easy for us. Some of them I'm not sure what does SPFID means. Maybe Springfield, who knows? But there is so many Springfield in the United States. So with the Springfield or Springfield or Port Everglades, it might be so many cities in the US, so we cannot sure. For some of them, we might be pretty sure like Pittsburgh, but for many of them, we are not sure what happens. So maybe just let's exclude them. For some projects, you don't have to, but here, I want to also look at the importance of a state on to predict my hotel categories. So it's the reason I care, but for some project you don't have to. So if you go rule-based row filter and click on it, come here. If you go down, you see that I said on the left side, I select the column that I wanted to work on it. So there's a province. When you click on it, then here in the middle, I click on like. I said if column, what does it mean here? The first row means insert province column. If you see whatever, Choconut Center or Choc, whatever, so make it true. If you go, look at here, I just said exclude true matches. So what does it mean? It just check the province column. In the first row, if the column value is Choconut Center, it would be excluded. Therefore, these rows here would be excluded because I'm not sure where are they from, which state. And I did same for the others. And by the way, province is a categorical columns. The reason I can use like, but if it's numerical, maybe you should use less, greater, equal, or something like that. As you see, I have so many values here, which I'm not sure where are from. So I just changed them to true, and true means exclusion because this command down there is activated. Also, I added an engine rule. Entry rule, you can basically modify your columns. You know, there is a point here. The column of province, which has the US state names, has too many states. We have 50 states, so there is something like you can talk about other like regions of US that are not a state, but and add them to those 50s. But let's say 50, and including states or other regions. So 50 subcategory. So if you want to do encoding, encoding just means similar to this text document. No, this one. So do you see for each word we have a 0 or 1, a dummy variable. So for each category of a state, we should have a one dummy variable. For example, for let me just, I think it's better to do it over my board. This might be much harder for you to understand what I'm talking about. So give me just 1 minute to connect my board here. Sorry, my whiteboard. So. Okay, could you hear me?
Yes.
Okay, that's good. So let's talk about one easier example. Let's say I have a column which is day of week. Let's say Saturday, Sunday, Monday, Tuesday, and Friday. So I cannot use this column for prediction because this is a textual document. You have two approaches. Either you do label encoding, or one hot encoding. For the label encoding, you just assign a number to each category. Let's say 1, 2, 3, 4, 5, 6, 7. And treat it as a numerical column. So convert numerical . The second one is one hot encoding, basically similar to textual document. You convert day of week to 7 value. So Saturday, Sunday, Monday, Tuesday, Thursday, Wednesday, Thursday, and Friday. So let's say for one observation of one of the rows, it happened on Friday. So it's not Saturday 0, it's not Sunday 0, not Monday, not Tuesday, not Wednesday, not Thursday, Friday is 1. What about Tuesday? So among these new added 7 variables, it's not Saturday 0, not Sunday, not Monday, Tuesday is 1, and the remaining are 0. So with either of them, you can basically convert that categorical column to equivalent numerics. And let me see if it's I'm recording. Yes. So you need to either of them. But there is a catch on one hot encoding. There's some caveats. When you have too many categories, like US states and other regions, let's say together we have 50. When you do one hot encoding, you make 50 new variables. Alabama, let's say Arizona, California, up to Washington. So, and they would be either 0 or 1. When you have too many categories, if you do that, you basically distribute the importance of the provenance column into 50 new variables. Maybe the state is a really important, or sorry, maybe the province is a really important variable here. But since you did one hot encoding and you make 50 new variables, you basically distribute or divide the importance by 50. So maybe none of them gets important. Also, when you have too many variables, usually it brings a lot of load on your machine learning algorithms. So what happens, they cannot predict well. Even having too many dummy variables, or 0, 1, it just brings a lot of load on your on your machine learning algorithm for prediction. So for such a things,
we try to avoid making too many dummy variables. One way is just recoding. So what I mean recoding, just let me see if I can erase. So hopefully my drawing isn't too bad today. Let's say mainland United States. Massachusetts is here, DC, New York is here, California is here, maybe Alabama is here, Colorado here, maybe Texas here, Washington here. What I do, instead of making 50 categories, I consider either East Coast, West Coast, and Center. So by E, C, and W. Now, instead of having 50 categories, I recode 50 categories to 3 categories. Basically, I want to use that province variable, but I don't want to make so many dummy variables. So at the end, it's just it gets non-important. It loses importance. Also, it might affect my machine learning algorithm in terms of predicting a highly accurate prediction. Any questions so far? So basically, this is the overall algorithm. So if a categorical variable either label or one hot encoding. If too many categories recoding. Okay, hopefully it makes more sense now. Let me go back to Knime. So in the rule engine, if you click on it, I just said whenever you see Arizona, California, Georgia, sorry, whenever you see, sorry, I just said in province column, whenever you see something like Arizona or something like California, convert to W, stands for West Coast. If you see Georgia, something like Georgia or something like Alabama, East. Something like Texas or Oklahoma, C, stands for Center. Now, you see I have made new provenance column. So instead of AZ, TX, or so many other states, we have like East and West, East, Center, and West. And you can keep adding, basically, since it was so many states, it just is some of them. But if you have time, you can just complete that rule engine module. And you also can do, for making dummy variables, we use one-to-many node. So look at provenance. I said take that column because it's the recoded column. And it asks to convert to dummy variables, or basically doing one-hot encoding. If you go to the data, you see now have EWC, East Coast, West Coast, and Center. So basically, I encoded the province column from so many states to just 3 regions. And they are just 0, 1. You see the values. So they are similar to the textual document, like 0, 1s here. Now I can use them for prediction. Also, for whom for familiar with Python and like to do with Python, let me see. Go to File, Preferences. It's not for everyone because it's a Knime class, not Python. But in case you want to use some module that needs Python, go to File, then go to References. Then you need to go to, again, Knime. So you see such a menu, click on Knime, and just click on Python. So as you see, if you have Anaconda, you can find the conda interpreter, but I'm just don't have Anaconda, just have Python. So I select Python here and then pick manual. Then here I browse to the python.exe, which is my Python file, and show the Knime that whenever you need Python, this is the place that you can find. So you also can do Python encoding. It takes a lot more time and not necessary. With one-to-many, you do exactly the same. So in case you're, but this is just for learning purposes. Categorical feature encoding basically uses Python, and it's not an efficient node. Even for your project, you don't have to. As you see now, when I run it, takes a lot of time. But with one-to-many node, I could easily make dummy variable. I could easily do one-hot encoding. Okay, so,
it's still running, so just wait. But basically, just exactly the same as one-to-many node. The only reason I put categorical feature encoding because it just uses Python engine to do one-hot encoding. So it's the reason I put it here, nothing else. So basically, as you see, just did for city. So here, I just said do, sorry, it's a label encoding. So basically it encoded the city variable. And if you go to the right side, you see we have city label, count, whatever distance. So it's one of the nodes that you can do label encoding. Also, instead of that module, that node that we call Python, you can use category to number. It does same and do just label encoding for you. Let me execute it super fast. Let me just open the node. Okay, let me. What happened? Selection. Okay, it should be the last column. So let me just open it again. Yeah. You just assign a number to each city. So it's a start from 0, 1, 2, 3, 4. If you click on it, you can change the start from, maybe you can start from 2, 3. I just said do label encoding for me and start labeling from 0 and increase by 1. Instead of that category to number, which is for label encoding, you can use categorical feature encoding, but it's not what I recommend. It takes a lot of time. Now, also look at date variables. Review it. So these are some, it's not numerics, but we have some like 2015-04-03, then T0, whatever. So we need to convert to the numerical equivalent. There is some ways to do that. Maybe you just focus on the year. So year is a numerical value. Maybe you focus on day of the week. So you can extract that. Or maybe you want to assign origin and just consider the distance from that origin in terms of time. I think I need to again show on my whiteboard. So
So I have a date column. Let's say 2015, 04, maybe 03. So year, month, day, then you have hour, minutes, and seconds. You cannot use it in machine learning algorithm. You need to convert it. So one way, just extract a component. For example, year, maybe season, or day of the week. Maybe seasons and year are affecting the reviews that customer leave. So you could consider it. Another way, just distance from an origin. I think instead of distance, here is better to say differences. Usually in the computer science, the origin is 1970, January 1st. And everything is 0. This is arbitrary origin. If you are not happy with that, you can make it to 2000. But doesn't matter. Let's say I'm looking at 2000, year 2000, January 1st. So the differences is 30 years time 36.5 days. So whenever you see that, this value is not good for machine learning. You put its differences, which is a numerical equivalent. Any questions so far? So how will you work with the date variable? Again, two ways. One way, extract a component like its year, season, day of week, or also differences from an origin. Like usually in computer science, they consider 1970, but you can just put any arbitrary origin. I wait 1 minute if you have questions. Basically, as you see, the goal of data preparation, one of the goals, actually, not all the goals, is just convert your data to numerical equivalents. So later you can use machine learning algorithms on top of them.
Hey, Professor, I can't hear you.
I'm sorry, I just saw that I am on mute. So let me go back. So with string to the date and time, I convert review.date because the string columns, if you might remember earlier, we talked about that. We convert to a date format. So I just said guest type and format, and I just said US is my time system. Then date and time differences. My arbitrary origin is 1971, but for you could be any origin. And I said count how many days are the differences of my each review from that origin. So differences in numerical value, I can use it for prediction. Also here, in the extract date and time fields, I can extract its year, quarter, month, but I'm just extracting day of the week. Because for me, maybe the day of the weeks could be associated to the quality of reviews or type of hotels that people choose. So if you, let me just extract it. Look, the day of the week column. Okay, by the way, look at two columns. One is the differences from that origin, and also another one is like, is it Friday, Saturday, Sunday, which day? Again, this column is a categorical column. I cannot use it for prediction. So does anyone remember when we have a categorical column like here, how I convert it to a numerical equivalent? Can anyone remember which nodes I used? We just review. I think you got tired a little bit today. I taught too much, but so similar to province or I mean geographical region, which is east, west, center. Similarly, I have day of the week. So here I did one hot encoding with one to many. You can use category to number to do label encoding, but it's what I did. So now I have 7 new dummy variables. So look at the first one. This one is Friday. So Friday is 1, the remaining are 0. I have another one here. This one, Sunday. So for this one, Friday is 0, Sunday is 1, and the remaining are 0. So day of the week, this column was a categorical column. I couldn't use it for prediction. I just convert to equivalent numerics. And the last, not least here, I want to exclude some columns that doesn't make sense for me or I'm not interested. So on the left side, for example, day of the week was a categorical. I already did one hot encoding for that. So I excluded, and also other columns that are not have. Let's execute. Right click and filter table. Now everything that I have here is numeric, except for the column that I want to predict, which is categories, type of hotel. So remaining is easy. Let me go to the meta node of prediction. I just do partitioning and use decision tree, and in the decision tree, my dependent variables categories. I think we had something similar. So let's just, since we already had these nodes, I'm just skipping fast. Let's look at the accuracy. First, the accuracy is 100%, so that's okay. Usually it doesn't happen, but it just today happened. Maybe because I included so many new variables that are helpful. Maybe it's the reason I get that much of high accuracy, 100%. Usually it's not the case. Usually you don't get 100%. So no worries. So if you want to, I strongly ask you to review this today class or watch the videos later if you shy to ask questions. Because we have important notes. For example, how to convert, how to recoding. For example, we have too many states, we converted to 3 regions, and then we did one hot encoding. Also, how we convert date and time. And also, we have an innovation here. Instead of just using textual document, I joined with other data, and used the other data for prediction, and I had a really good accuracy rate. Any questions? When you don't have any questions and I cannot see your faces, there's either 2 ways. One way, you understood very well, or you didn't understand anything. But I just wait for your progress in your project. So in case if you need more workflows or more explanation, I'll go over that. Basically for today class, I got your feedback from your emails, the group me text, class group me. So I understood maybe you need to expose to more workflows. By the way, let's say for your own project, you need to do something that are unique for your project. I didn't have time to do that. So what can you do? You can just Google it. So let me show it to you. Let's see, I didn't teach you how to basically extract numerical equivalent from date column. So you can just search for extract maybe year from date 9. If you look at the first link, somebody asked, I think she works for, yeah, she's a Knime member, and she explained for her. So she said, search for this node. She also taught him how to extract the year from date variable. Today I just work on the day of the week, but for your own project, maybe you need to extract more from the date variable. By the way, some of your friends has really good habit, and I give them some bonus because when they had some problems in their project, they reach me and they ask their questions, and it's the reason you have today's class, because I understood it might be challenging for them. And you could do the same, just keep me posted about your project. If I see there's so many similar questions from many people, I maybe make a new class or make a new video and explain some nodes and some workflows that help for your final project. I guess I talked too much today, and I have another workflow that might take a lot of time and just past the class time. So then that's for today. I think you need to do practice. So please just open these workflows, go different section of it, and basically just see maybe some of them could be questionable for you, or you have. Then you can reach me later and work together and we can resolve it. Anyway, that's for today. Thank you very much and have a great rest of the day.
Thank you, Professor.
Thank you.
Thank you, Professor.
Thank you, Professor.